A very good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series. The topic for today's session is predictive metrics in integrated ALM. And we have with us today Puranjoy Chatterjee. He is the Director Product Solutions at Coware Software Inc. Puranjoy currently heads the solution team for the Omnibus product line at Coware and has been working on multi-vendor tool integration for the past 6 years. He has been involved in architecture design and development of Coware's Omnibus integration platform. He has helped many companies discover the benefits of integrated ALM by designing, building, and deploying solutions for them. He has represented Coware at many public events and technical forums as a technical expert on tool integrations. Puranjoy will be giving his presentation till about 5:45 p.m. today, and I request all the attendees to start sending in your queries from 5:30 p.m. onwards, which I would be able to share with Mr. Chatterjee today. And without any further delay, I will now hand over the session to Puranjoy. Puranjoy, over to you.
Thanks, Srilagna. Good evening, everyone. So today I'll be discussing about predictive metrics in integrated ALM. Let me just share my screen. Okay. So predictive metrics in integrated ALM. So this will be dealing with mostly two parts of it. One is integrated ALM itself, what it is and how it helps us. And the second part will be on predictive metrics and how we use it in integrated ALM and what are the benefits associated with that. So let me start with the presentation. This is an overview of what I'll be speaking about. First one is what is integrated ALM, what are the benefits of integrated ALM, how does it impact quality, leading versus lagging metrics, then some examples of predictive or leading metrics, benefits of predictive metrics in ALM, and finally what does Coware offer in this respect. After that we'll go and have a short demo about 5-10 minutes where we will show that how this integrated ALM is producing real-time metrics which can be used to take corrective actions. First, let me discuss a little bit about what is integrated ALM. So integrated ALM or application lifecycle management is a totally integrated set of tools and processes that help organizations manage the complete lifecycle of application development. So it is a set of tools and also a set of processes that are used to manage application development or the entire application lifecycle, starting from the idea to getting it verified, defining the business requirements, the business case basically, then developing it further, doing the design, development, QA, and then deploy it into production, and also the maintenance cycle that follows that. So I'll talk about what ALM covers in the next part of the slide, but the integrated ALM also integrates the different teams, activities, platforms, tools, and processes. So these teams may be geographically distributed, as is the common scenario today. And ALM as such, it is a little bit different from what we commonly refer to as SDLC. I'll be explaining that here. So as I said, it spans from the idea to the end of the application's life. And within this application's life, the SDLC or actual development of the software, that cycle can repeat. So if we look at this diagram over here, the idea starts over here, and this is the initial stage where we are defining the requirements and doing all that. So the SDLC, this green part is an SDLC cycle which is used to actually develop the product or basically the work products that are going to be delivered. and then it goes into deployment, which starts the operation part of it. So it goes into operations from here, and during the lifetime of the product or application, this SDLC might be repeated. You may need to upgrade the software, or you may need to enhance it and keep it up to the times. So these cycles continue as long as the application is in use or is in operation. And finally, every application or product has a life, and there will be a stage where it will become obsolete and the pain point will basically no longer exist. So the product or the application will be discontinued, or it can also happen that a newer, better product comes in and replaces this. So that is the end of life of the project or of the application. So ALM consists of this entire cycle, and not only the SDLC parts. Multiple SDLC cycles can be repeated within the life of an application. The next point is, how can we implement integrated ALM? So there are three approaches available in the market today. The first one is best of point-to-point integrations. So point-to-point integrations are specific pieces of code that are written to integrate different applications or tools that are used in the ALM. The advantage here is that we can use best-of-breed multi-vendor tools, so there is no vendor lock-in over here. You can use tools from the leading vendors and connect them together. And also another advantage is that the integration code can be handcrafted so that it caters to your exact use case. But the problem is that if you are using more than 2 or 3 tools, which is actually the most common scenario, that people are using 5 tools, 10 tools. So the point-to-point integrations cannot scale out to support that. It becomes very complex to maintain, and each piece of code has to be maintained and monitored. The tools may change, their versions change, their APIs change. So to keep up with those changes, you need to work on multiple pieces of code. So for example, if we have 10 tools in the scenario and one tool changes its version or API, then you need to work on 9 pieces of code which are connecting this tool to the 9 other tools. So it is not a scalable model. It cannot be used for more than 2 or 3 tools. The next option is single vendor all-in-one solutions. So single vendor solutions are like one particular vendor is providing all the tools for all the different silos of software development, and these tools are often connected with each other. So there's a integration already available off the shelf, but problem here is that the tools have to be from the same vendor. So you are basically locked in with the vendor, and this is a dynamic environment. So today the tool that you're using may be replaced tomorrow by a better tool. Your process methodology may change. That may require more tools to come in or different tools to replace the existing ones. And over there, if you're locked in with a particular vendor, then that becomes a serious limitation when you're choosing the tools. Then another problem here is that each integration is based on vendor's guideline of use. So you cannot exactly suit it to your use case. The simple use cases will of course be supported, but if it is a complicated use case, integration use case, that will not be supported off the shelf, and it is difficult to customize these pre-coded integrations to suit your exact needs. And here the vendor does all the integration, and you won't be able to use the best of breed tools. You have to use all the tools from the same vendor, and all the tools may not be the best tools of those areas, and you have less control over the integration rules. The third option is ALM integration middleware. So this is basically a dedicated piece of software that is doing only the integration part. So it's connecting multi-vendor best-of-breed tools, and you have to have the adapters to connect each of the tools to the middleware. The customer can themselves create their own adapters because most of these middlewares, they have open APIs available, and the integration rules, they are not coded into the components of the middleware, but they are left open for the end users or the customers, basically the administrators, to configure them. So this is by far the most flexible solution and is the best fit when you're using multi-vendor tools. Next, what are the benefits of integrated ALM? First benefit is data visibility across tools. So get to see that what you are missing. For example, if I'm a QA engineer, I work for a QA team, and we are developing a product, and the requirements are being defined in a different tool, and I work in a different test management tool. So unless I get an email, if these two tools are not connected, then I have to depend on emails or phone calls to know that a new requirement has come up. And that requirement, when it comes to me in the form of a document or an email, I type it in to my test management tool, and then I start defining the test cases against that. So this is when we are not using integrated ALM. But if we are using integrated ALM, the requirement, as soon as it is approved in the requirements management tool, it will automatically show up inside the test management tool as a new requirement, new test requirement. So the tester can easily, whenever he opens the test management tool, will be able to see the new requirement and start working on it immediately. So there's no time wasted in waiting for manual communication. And the data from the requirements management tool becomes visible inside my test management tool. Not only that, it remains synchronized, so whenever changes are happening in the requirements management tool, those will show up inside my test management tool. So that sort of removes the problem of working on obsolete requirements. Often it happens that I was working on requirements, and after 2 days I got a message that the requirement I was working on is no longer valid. It is or it has changed significantly, which requires my test cases to be changed as well. So these sort of wastage of time are avoided if we are using integrated ALM. The second important point is traceability between objects in different tools. So traceability is specifically when we are working with requirements, specifically the traceability is easy to maintain in requirements management tools, but when we try to trace it to artifacts that are being managed in other tools, it is very difficult to do that because none of these two tools support relationships between their artifacts with outside artifacts. So what is required? We need to probably copy the IDs, put it in an Excel, and maintain it manually. And that is a cumbersome process. But in integrated ALM, what we get is we get the ability to establish traceability between the objects that are managed in different tools. And that makes our life very easy in terms of change management and impact analysis. And that is very critical when we are talking about the quality of software. Third point here is process automation across tools. So often it is required that small pieces of automation can gel together the entire scenario of all the disparate tools and can save a lot of time which is spent in handshaking between these tools, between these different teams which may be again geographically separated. So if we can automate these processes, that the handshaking happens automatically and people are notified immediately if they need to work on something. So those kind of process automation should also be possible in an integrated ALM scenario. And the fourth point and probably the most important point, is the ability to get dashboards and reports from data that is coming across from different tools. So it produces real-time metrics and KPI of related data from various tools. This is important in the sense that if you are asking for a report from a management point of view, and your particular project team is using, say, 10 tools, then probably 4 or 5 different teams need to get busy by taking out the data from their respective tools and sending it to someone in between who will be consolidating that, aggregating that manually in maybe a Excel or something like that, and manually produce this report. So that's first of all going to take a lot of time, and secondly, that is an error-prone way of doing things. But in integrated ALM, you should be able to get that at the click of a button, because the consolidated data from all tools is being used automatically to produce the dashboards and reports. So how does this impact quality? Or what do we actually gain out of this integrated ALM? Okay, so I have 10 tools and I mean they are integrated. So what's the big deal? Even when they were not integrated, we were doing projects and we were delivering projects. So what is the difference? The first answer to this question is that yes, we were definitely delivering projects before the time of integrated ALM, but there's always a better way of doing things. We can always improve on the efficiency. We can improve on the quality of work that we were doing, and I'll be focusing mostly on the quality part of it today. So how it helps to improve quality? First point is it provides the right context for every stage of ALM. So let me give you an example. I am a developer. I am writing a piece of code in, say, IDE like Eclipse. And while writing that piece of code, I do not have much information available to me, except maybe the email containing the requirement or the specifications document, which again may be quite old. But if, on the other hand, I get a plugin inside Eclipse, which is going to show me all the current artifacts from the requirements management tool, that's going to be of considerable help. I will be able to see the latest requirement and also some more requirements that are linked to that requirement, so that the entire context is available to me. Also, if we look at the downstream, I can get a view of the test cases related to this particular requirement and sort of can implement test-driven development in some sense over here. So that is definitely going to improve the quality of the first piece of code or the first cut code that I'm writing. And we all know that we should get the quality right in the first shot. That is much better than trying to improve it after writing the code. The second point is that integration ensures code quality and performance throughout the lifecycle process. So quality of work is validated at every stage, and defects are caught during the process instead of at the end of it. So as and when you are writing the code or you are releasing your modules to the system, you should get the direct feedback of how this class is doing, or how this module is working, how many defects are coming up, and at that stage you should be able to rectify it rather than wait for the system test after everything is integrated to know that, okay, so my code produced hundreds of defects, rather than if you check in the file and you get a live feedback that okay, so my static analysis failed and I got 5 defects in the static analysis phase. So that's going to help me rectify it much earlier, and the earlier I rectify defects, it's better for the project in the cost sense. It's much cheaper to do it early. The next point is gain greater insight. So what is the quality of the current release that we are working on? Which part is not stable yet? What corrective actions are needed? So this is, if you're looking at it from a higher perspective, say for example the project manager or the module lead is looking at the integrated ALM dashboards, so he or she would be able to see that what is the current quality of the release that we are working on, or which part is not stable, or maybe the requirements are too volatile. So these kind of volatile requirements are definitely going to impact the quality at the end. So he or she can focus on that area and talk to the concerned person that we need to do something, we need to change something in the requirements management so that the volatility is kept low. These sort of corrective actions can be taken. Then best practice processes can be enforced across tools and artifacts. So the integration between all the tools can provide you a common platform where you can define your processes and make sure that basically all the silos are using the best practice processes. It's not just a definition, but it's something that is being practiced, and whenever people are not compliant to it, or the practices or processes are not adhered to, you can get red alerts or flags saying that okay, so see it in the next day morning when you open your Outlook. So that should not happen. You should be able to see it immediately. And say for example my development is complete for a module and I just want to update that task and say that dev is completed, please run the integration test or something like that. So I should not be required to do this communication manually or open up the task management system, go there and complete the task. I should be able to complete this simple work or simple job of updating my task from inside my IDE itself. And coming towards the end, this is really important, that getting the real-time actionable metrics to take corrective actions. So this is actually the thing that we will be emphasizing on today, that how these real-time actionable metrics can change the course of a project. And we will be able to manage change with confidence. We will be able to know the impacts on related artifacts automatically, and we will be able to notify those stakeholders early in the cycle and also manage these changes with confidence that yes, all the impacts have been taken care of or considered. So let's move on to what are the different types of metrics that are used in common software development scenarios. So there are two types. One is the leading metrics. This is the area of focus in today's discussion. And the other is the lagging metrics, which we are more familiar with, like defect count and schedule variance, cost variance, and your earned value matrices, all those things. So what's the difference between these two, and why leading metrics is important? So leading metrics are basically the performance drivers. So these are the processes or the tools that are used to get the performance, whereas the lagging metrics are used to measure the outcomes. So using these performance drivers, the processes and tools, what we have delivered, those are measured in the lagging matrices. So leading metrics talks about how the outcomes will be achieved, whereas lagging talks about what are the outcomes that was achieved. So this is like looking at it after the job is done, and leading is like looking at it while we are doing it. So that gives us early warnings about being on track or moving away from track, producing more defects, more unit test defects, or the code complexity is such that it is likely to produce more defects. So those kind of matrices are produced at this stage. And on the other hand, at the lagging ones, we get to see the final performance. So what was the total number of defects, critical defects, the defect density, and all that. This is measured at the process level, whereas the lagging matrices are measured on the outcome. And the leading matrices can be used to make corrections now that can improve the end result. Whereas the lagging matrices, when you are getting those matrices, it is already too late. So it tells you how well it was performed or how poorly it was performed. So these are the causes. The leading metrics are the causes. So how well you are complying to the processes and whether you are following all the steps or you're taking shortcuts, that predicts what will be the effects on time, cost, quality, and of course customer satisfaction. This is one factor which is not often counted or measured, but it's very critical, because even if you deliver on time within the proper budget and with the proper quality, you may be actually not satisfying the customer because their requirements may have been slightly different, and your requirements management part, although you think it was right, it was not actually right, or the requirements has evolved over time which you could not capture and put into your software. So customer satisfaction is also an important thing that should be measured as a lagging matrix. So leading matrices are predictive and proactive, so they are done at the time of performing the work, whereas the lagging matrices are reactive, so you get the data and based on that either you can use it historically for doing estimation for future projects, or you can use it to pinpoint what was the cause for this failure. So some examples of leading matrices are like process compliance, requirement stability, or the opposite, basically requirements volatility, change request backlog. So what is the rate at which change requests are coming in, and how many change requests are still left, then the velocity and trends of the project. So these are leading matrices based on real-time current data, and if you keep track of these matrices and do the corrective actions properly, then it's bound to impact positively on the quality of what you're trying to produce. Whereas examples of lagging matrices are like the typical schedule metrics, cost metrics, and defect metrics. So what was the schedule variance and cost variance, these sort of matrices. And this is a very common comparison in the industry, that leading matrices are known to be the windshield of your car, and the lagging matrices are like the rear view mirror. So you cannot drive the car looking only at your rear view mirror. You need to look to the windshield. So if your windshield is covered with snow and your rear view mirror is showing you the perfect picture behind you, it's not making much sense. You need to look ahead so that you can drive your car, avoid the obstacles that are coming up. Okay, so let me give you some examples as to how these predictive matrices can be used to determine which areas of the product or the application will be faulty. So these are some of the information gathered from across the industry or from our daily experience of producing the different applications. So let me talk about some of the matrices in the requirements or design phase. So completeness of requirements, they generally are a good predictor of fault proneness. So from our experience, we have seen that incomplete requirements are like a major factor of producing faulty products and causing customer dissatisfaction. By the way, a lot of the defects that are captured in the ALM process actually generate from the requirements management phase. In fact, the percentage is more than 50%. Then the volatility or stability of the requirements also impact or also predict that the final outcome will be stable or not. So if the requirement is being worked upon, the version is changing regularly until the day you are releasing it for QA, then it can be assumed that the code that has been written to implement this requirement also has got a lot of churn. It has been checked in multiple number of times. Something was done, again removed, again something else was introduced. As and when the requirements are changing, the coding is also changing to support them. And this is a typical scenario which produces a lot of defects. Then design defect density also predicts how faulty your application will be, because the design, as it is very much higher up in the workflow, so if you have a lot of defects in the design and they were corrected multiple number of times, most probably your final application is going to be quite faulty. Then also the complexity of design, the data flow complexity, is also one of the predictors of fault proneness of the final product. So the more complex the design and the data flow, you can expect that the number of defects discovered over the life cycle of the project will be much more. Looking at the metrics that are used in coding, so one of them is the static analysis matrices. So when we do static analysis and we get to see that one particular class or a module or maybe a particular developer, whatever code he or she is writing, is failing in the static analysis, producing a lot of problems, then that is going to be a predictor that this particular module is going to produce a lot of defects. Then the cyclomatic complexity of the classes, the higher the complexity, the chances of producing more bugs or defects in those areas. Depth of inheritance is also another measure in the coding stage that that can predict that if you have a long depth or a very deep inheritance, then there are chances that some of the cases are not handled and it might produce defects. And code churn is another one that I said that the number of times a particular code has been changed and modified and reworked on, chances of producing a higher defect density is high. So these numbers are not like absolute numbers and that have a very linear relation with the number of defects produced. So there are in between these matrices and the prediction, in between that there are some models that are used for predicting this behavior. So these are mostly statistical and probabilistic models that are used. So I'll have a short discussion on that in the next slide. And predictive metrics in testing, of course, code coverage is a good indicator that if your test cases are covering only 40% of the code, then the remaining 60%, when it falls in the hands of your customer, it's going to produce some defects. So these are some of the different predictive models that are used in the industry to come up with the target numbers, and I will not be going into the details of each of the different models. So these are basically dedicated subjects of study by themselves. So discriminant analysis is mostly like you are changing some of the parameters and how it's going to affect different parts of your product. Classification trees are based on types, how you are classifying your modules and your defects. Bayesian belief network, or popularly known as BBN, is also a probabilistic model Then another one is constructive quality modeling for defect density prediction. This is also used to predict the number of defects in the final product and accordingly make changes now so that it can come down. Then Rayleigh curve is a model used for predicting the defect discovery. So at which stage how many defects are going to be discovered. And so this is very funny in the sense that say you are not discovering as many defects. According to the curve, you are supposed to get say 50 defects in a particular time frame, and you see that you have got only 5. So that is a red signal for you that your testing is not happening properly. Otherwise, at this stage, it should have produced more defects. So these are the different relationships that occur between the existing numbers, the current numbers today, and what it is predicted to do when the final product is delivered. Then multivariable linear regression. So these are done by changing the values of more than one variables and seeing that how it is going to impact the final product, and based on that these variables numbers are matched to the actual numbers that are coming up from your code development, application development, and if they are not matching, then the corrective actions can be taken at that stage. And of course, Monte Carlo simulation can also be done on the requirements part, where the volatility and overlap of requirements, these parameters can be modified to see a what-if scenario that if we change the volatility to some number below the current one, how is it going to impact my final quality. So these are some of the predictive models used today. And the benefits of this predictive metrics in ALM are that they predict the likelihood of meeting your schedule milestones, and that's very important. If we are going to have a schedule variance, the earlier we know that, the better for all of us. Then they predict the delivered defect density of the software, what is going to be delivered. It's not yet delivered, but what will be the defect density after delivery. Then it helps to develop the strategies for mitigating these identified risks. So if the delivered defect density is too high, that's a huge risk for the project, and your customer is not going to like it. So the customer satisfaction measurements are going to suffer badly. It also helps to estimate time and cost that is spent on rework for defect removal. So that is also going to impact your schedule variance, because if you spend man days after man days on trying to get rid of the defects at a later stage of the project, then that's going to definitely mess up your estimated time plans. And it also helps us to develop maintenance plans and estimates that, okay, so this is the expected delivered defect density, so we can expect that on an average in 7 days we will be facing 20 defects from the product, so I better keep 2 guys or 3 guys on hold so that they can work on those defects. Okay, so coming to the Covare part, what does Covare have in this respect? So we have platforms and services for integrating multi-vendor tools to provide a unified software development environment. This will provide an integrated view of all the ALM tools. The data visibility is going to be very good across all the tools. We also provide a central repository where all these data from all the tools can be mirrored into this repository, and that can be used for generating your consolidated reports, tracking data, traceability, dashboards, all these things. And the traceability, reporting, and dashboards, these happen on real-time consolidated data. So the data is synchronized from the source tools, and then the reports are produced. So if you make a change now in your system, it's going to show up within a minute in your dashboarding panel, and that's going to help your manager to take corrective actions immediately. Then we take care of process automation across different tool boundaries. The Covare product can be used to measure process adherence, and thus it can be used to enforce process compliance at different stages of the software development or ALM. And our integration technology, we call it the Omnibus Integration Platform, that is built on SOA architecture, and it's based on the ESB model, so it's very easy to build connectors and hook it onto the bus, and that's immediately going to get connected to all the other tools in the bus. And we have connectors for all the major tools in the market, so I'll be showing you a slide regarding that. This is the architecture of Omnibus from a high level. We have a central processing engine or the bus and separate adapters for separate tools, and some plugins are there which enable the IDE users to get a view of any of the artifacts being stored in these tools. They can see it from within their IDE, modify it, and also create new items inside those tools directly from their IDEs. And the Covare application here is a web-based application that is used to configure the integration rules. This is the current Covare scenario where we are supporting 45 plus tool integrations, and if you look carefully, there are integrations available for all the different silos of software development or application lifecycle management, so Requisite Pro, RRC for requirements management, and also some tools like SonarQube, which are used to generate real-time matrices from the code, and also static analysis tools like FindBugs, FXCop. These are also integrated so that these matrices can be produced real-time and can be used to predict the future matrices. So saying that, it's time for a short demo where I'll be showing you how some of the predictive matrices are working in some real projects. So let me just start with the presentation, start with the demo here. Okay, so what we see here is the Covare application. This is a particular artifact that we are tracing. It's the build management, build artifact. So there are different artifacts available under each of these headings. So under project management, you can see some artifacts, requirements management. And so we were in build management and looking at the builds over here. So these are three different Eclipse projects that are being seen in this particular view. And if we look at these numbers, so these are the project names, and this is the cyclomatic complexity that is there in these projects till now. And these are all current projects which are being worked on. And the predicted issue number is showing up over here based on the models that we have used to derive this. So this is a real-time current number, the complexity based on how you're writing the code. This is showing up. And this is the prediction based on the models that it predicts so many defects will be produced. And you can see the ratio between the complexity and the predicted number of issues is also quite close. In fact, this one has a variance, but the other two you can see that 0.23 and 0.2 is the ratio between these. So this depends on the complexity of the model that is used to generate these prediction numbers. Now what I will do is I will go into this project and I will modify the code, and based on this integrated ALM solution from Covare, we will see that that is going to immediately impact the complexity and also the number of predicted issues. So let's go into the development machine and make a change in the code. Okay, so I've logged on to my development machine, and we can see that this is the project name over here, CoWare internal project. And what I'm going to, okay, just give me a second here. Alright, so what I'm going to do here is I will delete a particular class file from this project, and that should impact my complexity. Okay, so I think the remote desktop is not connecting properly. Okay, so there you go. I get to see the delete message now, and I'm going to just delete this, and I'm going to build this project. So this is the end file used for the build, and I'm going to fire the build here. So let me go back to the metrics once. It was showing that complexity is 4.8 and the predicted number of issues is 21. So this depends on what are the lines of code, and so a lot of parameters are considered to come up with this prediction. Now let me go back to this one, and the build is successful here. So let's go back to the monitoring screen that I was looking at. So this is my CoWare application showing the build, and let me just refresh this to see that the changes are happening or not. So 4.8 and 21 and 0.23 are the numbers. Those should change. Okay, not yet changed, so the data has not yet arrived into the ALM application. We are not yet able to see the change. I'll give it a few more seconds and refresh it to see whether the data is getting updated or not. Not yet. Alright, it's not yet here, so it will take about a minute or so to get refreshed. So this integration platform basically works in an event and action model. The event that is being trapped is build has occurred for this particular project, and what that is going to produce is this event is going to come to the integration bus, and there are some rules over there that's going to be processed, and once they are processed, the data is going to be sent to the ALM monitoring tool or the CoWare application, and that should show me the current data. Let me do another refresh. So it's not yet here, it's taking longer than usual. Let me wait for a couple of more minutes to see whether it's coming up. Meanwhile, why don't you start sending your questions to the moderator so that we can take them up. Not yet. was successful. Don't know what's wrong. Let me just try and build it once again. I think the number has changed, isn't it? The predicted issues was not 30, it was 21 or something. Let me just check. Yeah, so actually the matrices have changed. I did not notice it. It is showing the ratio as 0.16. This was earlier showing up as 0.23. So as and when the builds are taking place, the matrices are changing real time, and also the prediction is changing. So if this goes to an alarming area, people can take corrective measures. So this is just one matrix that I have shown how it works in an integrated ALM scenario, but there can be matrices, similar matrices for requirements management, project management, and your defects, testing, coding, all the areas. So that brings us to the end of my demonstration, and also the presentation is done. So it's time for questions. I would request the moderator to share the questions with me, and we can start answering them.
Thanks, Puranjay, so much.
So I can see the questions tab.
Yes, I have assigned a bunch of questions to you.
Welcome. Okay, so yes, I can see the present questions tab. I've opened it up. Let me look at the questions that are available over here. Okay, so the first one says, does these metrics align with any standard like CMM or ISO? So basically the answer to this is yes. I mean, that depends on how you are implementing the integration framework, what are the integration rules, what are the matrices you are calculating. So it's not, I mean, the purpose of today's presentation is not to say that these are the matrices that you must use. So you can use the matrices as defined by CMMI or your ISO processes that you are following. So, and regarding the Covea solution, any process workflow can be configured inside the solution. It's a very configurable and flexible solution, and you can determine any number of matrices. You can write your own formulae to calculate them. So that's it. The next question here is, what role can ALM play in communication management? Okay, so and this is a good one in the sense that ALM is, of course, ALM is the broader thing, that is the application lifecycle management, but I think the question is related to integration or integrated ALM, how it can improve the communication. Yes, so you can set up rules in the integration framework that based on certain triggers or certain events, you can configure it that certain stakeholders will be communicated about the change or about such an event happening. And this can be tied up to certain matrices. So for example, if we see that the schedule variance is crossing a particular limit, and we have set up the rule that this kind of an event should send a notification to the customers, stakeholders, or the management stakeholder in our company. So that's going to happen automatically, and your management is going to get notified that, okay, this project is in trouble, it's running late, so we need to do something. So this is, I would say, this is a sort of helping out in the communication management. This communication otherwise would have happened manually by the respective people in charge of doing that based on the communication plan as detailed out in the project charter. So I think that these kind of rules can be configured into the integrated ALM scenario, and it can bring in a lot of automation regarding certain urgent communications that are required. The next question is, can we integrate Coware plugin into Maven or any other good build tools? Yes, definitely we can integrate Coware plugins into Maven and other tools, like we're already integrated with tools like Ant and MS Build, and even TFS Team Build, Microsoft TFS Team Build, and some continuous integration tools like, for example, Hudson or Jenkins is also integrated. TeamCity integration is currently, we are working on that, so that should also be available shortly. Okay, the next question is, what is the usual time and cost involved in setting up an integrated ALM across the board of engineering team? Okay, so that would depend on a lot of factors. For example, how big is the engineering team, how many different tools are being used for the daily use of this engineering team, and so how many locations are being connected. So based on that, the integration adapters need to be deployed, the use cases need to be identified, and based on that, that needs to be configured and tested, and there's usually I mean, it's not directly rolled out into production, since this is a critical thing, and if it shows up wrong numbers, then that's going to seriously impact your project execution. So first we set up the integration platform on the dev environment, connect the necessary tools, check out manually all the matrices, whether they're being produced correctly or not, and then we move it to the secured test servers, and then once it is stabilized and tested, then it is moved to the production servers. So it has some time involved in the actual production rollout that can range, if we are looking at 2 tools and simple 4 or 5 use cases, then that can take about a week's time to do the installation from scratch, do the configuration, testing, and then moving it up from your development to staging and production instances. So that is a 2-tool scenario, but usually the tools are higher in number, and the way it is implemented is in phases. We start with 4 or 5 most popularly used tools, and once the integration is in place, rolled out to production, then we start integrating other tools of the customers into that scenario and making the functionality be available incrementally to the end users, because too much of change in their work pattern is also going to impact negatively in project performance. So we make sure we address the most important pain points first, and then incrementally we keep on adding the tools. Okay, so I can see another question which asks that can these metrics be customized based on organizational needs? Yes, so that's also a good question, and yes, of course it can be customized. And the Coware integrated ALM platform and the Omnibus integration platform, these two are very configurable in the sense that there is nothing hard-coded over here. So it provides you the platform, it exposes the metadata from the individual tools, and you can configure your own matrices, you can configure your own dashboards, reports, you can have your interactive dashboards. Then these dashboards can be used to drill down, and those can those can be customized by individual project teams, and of course organization level also, and individual teams can do that also. Okay, so another question is there any feature to send the notification to any central electronic device like a central monitor? Yes, of course. So basically you can set up the notification also. You can make it role-based notification so that it is sent to the project manager or the module manager, or you can send it to fixed email addresses also, or you can send the notification via integration to certain APM tools where it is monitored that what are the errors coming up and things like that. You can also do that. So another question is, what is the time taken to develop adapters which are not already existing in Coware? Okay, so typically it takes us around 6 weeks of time to develop a new adapter for a tool, and this of course varies a little bit based on the complexity of the tool and the different areas of software development that is being addressed by the tool. So, but on an average it is 6 weeks. So I think we are running short of time here. I will take this question. Can we put some conditions on integration based on number of defects? Yes, so all these integration flows, they can happen conditionally. The way we set it up inside Coware is that you define what is the event you are going to listen to, and you define that what are the criteria or conditions that this event must pass so that it is processed and some action is performed on another tool. So yes, you can you can create multiple conditions, complicated, complex conditions, and also simple ones based on which the events can be filtered out. So another question is how we can connect or we can create adapters for tools from different platforms, so .NET and Java. Okay. Yeah, so we create adapters for tools that have to these adapters conform to a particular interface, and these adapters can be built on Java, they can be built on .NET or any technology. These are basically web services. The adapters are actually web services. So you can develop a .NET web service or a Java web service. It doesn't matter, and the tool, the target tool, whether it is Java or .NET or something else, is absolutely immaterial. We can connect tools from different platforms. So I think I've run out of time here. I will hand it over to Srilagna, the moderator. Thank you everyone for spending your time with me and going over this topic of predictive metrics. Over to you, Srilagna.
Thank you so much, Puranjay, for taking those questions. I'm sure some of our attendees probably would want to ask more questions, and I would request them to take them up offline with you. They can either email us the questions directly or come on techgeek.com and post them on the discussion forum. And Puranjay, you can also visit us and post your answers on the discussion forum later on. Uh, Also, the recording of today's session will be available by...
Absolutely, I'll do that.
Thanks so much. The recording of today's session will be available on TechGeek tomorrow by afternoon. So those of you who joined today's session a little later, you can always go back and take a quick look at today's presentation there. And once again, thanks Puranjay for taking time out, and thanks. Hope to have you again on TechGeek forum in the near future. Thank you so much.
Thank you everyone. Bye-bye.